Okay, thank you very much. Thank you for coming here. That was a fascinating piece of big technology. Now the next presentation is for those of you who may or may not have a mainframe, but for sure you will have endpoints, you will have networks, you will have mobile devices, and you will use cloud services. And how to better protect them against zero-day exploits, yet unknown threats will be the topic of the next couple of minutes. And the case I would like to make today is, in spite of all the analytics and of the real-time monitoring and the machine learning that is currently being hyped everywhere, and which is absolutely necessary. I agree that people have to be supported by automation, by machine learning, by artificial intelligence. But still, the more you protect your networks, your endpoints, your cloud service, the less effort you will have later on cleaning up and detect things and analyze things and respond to things. So let's take a look at the proactive approach, how to secure your IT. Maybe just introducing a little bit Rost & Schwarz. That may be a company that is not known to everybody in the IT space. We are known in many other industries. So if you look at your smartphone, the one that you are carrying here, the likelihood is more than 90% that this has been tested or developed using test and measurement equipment from our company, from Rost & Schwarz. If you look at TV broadcasters, and I think the one even in Riga here, the TV tower, the amplifiers inside is very likely Rost & Schwarz amplifiers. So we are a large electronics group as well. There's lots of video processing of Hollywood movies being done on digital systems supplied by our company, and now we are making a step into security. Air traffic control systems is also one of our successful businesses. And even in this business, we have introduced virtualization and separation. So Rost & Schwarz air traffic control systems, for example, they support resource sharing between the air traffic control systems of Ireland and of Iceland. These two share actually the air traffic controllers. And if somebody calls in sick in Dublin, basically some guy in Reykjavik will jump in for him and connect it virtually, and they will be able to secure the airspace. And this is being done using radios and software systems from Rost & Schwarz as well. Of course, maybe this all is new to you, but latest after this presentation, it will not be new to you anymore that also Rost & Schwarz has been building and is still in the process of building a cybersecurity unit. And we are actually one of the Europe-based manufacturers with the largest and broadest product portfolio and solution portfolio that is available here on our continent. Just to give you a rough idea where we are, obviously we are very strong in Germany. We have 8 locations now in Germany. We have 2 in France, 1 in Denmark, and we are looking to further increase our presence. And these are the locations where we do have R&D and operations in general. These are not all the locations where we are present. So actually, Rost & Schwarz Group has offices, for example, in Riga across the river. It's very close. And we do have our colleague here. So if you have any questions, just come back to me after the meeting. So what's the story for today? Very, very short. So after reading this, maybe you could either go and see the next presentation or listen to the proof I'm going to provide on this storyline. So IT security solutions actually today, they are facing a paradigm shift. Conventionally, IT security solutions are pretty much looking after what's happening. So they download huge signature databases of malware, and if something coming into your network or into your endpoint matches the signature of this known piece of malware, a red light will flash and the thing will be blocked and so on. But it's reactive. It's the only thing that you can do is you can filter out things that have already done harm at your neighbor's IT, that have been discovered as well. But you don't find the things that are not known yet, or they are specifically tailored to your organization. So these solutions, they don't do the trick anymore, as you know. So against these zero-day attacks, which are actually attacks that are not known yet, they are not disclosed, IT security solutions based on proactivity on security by design need to be deployed. So they actually need to reduce the attack surface of your IT. And they will be based on topics like separation. They will look at rights connected to the data, not only to the users. And of course, they need to look at usability, because the best technical solution is not worth a lot if users keep on making the same mistakes and thinking they encrypt the thing, but it's not actually encrypted because of bad usability design. And one important thing is the reality, especially for us as a European manufacturer, and maybe for you as European-based customers. We have to face it that most IT solutions and even most IT security solutions are not being developed and manufactured here in Europe on our continent. So everybody is using solutions that are coming from other parts of the world, from America, from Asia. So our chance here in Europe is not so much to build up the next big IT equipment and make it secure. So just looking at the mainframe that we saw, it's probably not a good idea to try to build the European mainframe and make it even more secure. No, we should take things that are as a reality and try to build solutions on top of that. That you can keep running the efficient, the market-leading equipment, but secure it the European way. And Europe is a little bit particular here. We'll talk about this later. So I will give also, as the end of the story, a number of practical examples, especially how to separate and secure IT/OT networks, take a brief look at one security aspect of endpoints, and also look at an innovative approach how to secure cloud application usage. So we do actually have customer references in all these domains, and I think it's worth sharing it with you. So the beginning of the story is the problem is reactivity. And many of the things that you have heard over the past years and also here at these conferences, they look at things that are happening, and then later on they try, based on references they have from elsewhere, try to decide, is this a good thing or a bad thing that happens? But either somebody else, your neighbor, your competitor, or yourself will already have been attacked. If it's a new attack, these systems will most likely not find it in time. And you have maybe heard that most of the targeted attacks, they remain undetected for 100 or 200 days, typically. So these guys are really, really clever. And a good thing is not only to try to analyze and detect them once they're already there, but a very good idea is also to prevent them from entering in the first place. And there's a couple of things we can do. Of course, it's not only our wisdom. It's even one very important company that was living on antivirus for a long time, and now they have more innovative solutions as well. But even they said, the antivirus company said antivirus is dead. It's not really dead. You still need to have it to protect you against these untargeted attacks, but it doesn't do the trick on its own anymore. So, with regards to the digital transformation, we are facing a number of facts that we have to take into account when we look at solutions. So especially the majority of cybersecurity tools today is industry agnostic. So the tools address Office IT, plain Office IT, exchangeable basically hardware, standard operating systems and so on. This is valid for processes, for security processes, for information security management systems, and for the tools and technologies as well. But increasingly, the digital transformation brings new elements into our networks, new kinds of endpoints. Legacy systems sometimes that you plug an internet adapter to the big machines processing tons of material, and suddenly it's internet connected, but it doesn't speak the same language as a standard mobile phone. It doesn't speak the protocols of PCs and so on. So your security measures they need to adapt to this new world, and also they have new chances of keeping this new machine-based, cyber-physical system-based equipment clean. And then one more thing to consider is Europe is special. And this is actually a very good year because we have seen the European Commission last year and this year bringing new regulation on top, especially the GDPR, which is being talked about a lot here, and also the NIS, Network Information Security regulation, that makes Europe a special place. And if you go to USA, if you go attend RSA conference and so on, these guys, they all talk about how can we keep our business alive in Europe, because there's new regulation that we don't know about and we don't really understand about it, but there's huge fines. And these vendors, they're trying to comply, to make their products compliant to our European regulation. So sometimes it's worth looking also at people who develop products here and who are born and live in the privacy mindset that we do have here on the continent. On the other hand, for us as vendors, it's a bit more challenging, because our home market is Europe, and it's like 28, 29 countries and almost as many languages, and our market is very fragmented. It's a challenge, but it's also a chance for us. So what is all about this paradigm shift, a very theoretical thing? So I'm trying to provide the analogy of the automotive world. So we all know the airbag. And nobody would actually buy a car today that doesn't have an airbag. When I was a kid, actually, the safety belt was introduced. And I still can remember, I was a little boy, it was in the 70s. All the complaints and the lawsuits that were filed against the security belt, because it kills your health, and after driving with a seatbelt on for 5 years, you would inevitably die because it constrains all your body and stuff. So there was crazy objections against it. So there was some regulation, and finally people had to pay fines, and safety belt was introduced. And now what do we have? Based on this basic level of security that was mandated by the government, many other things evolved. For example, airbags. And airbags are a very, very good thing once an accident has happened, because the airbag makes it hurt much, much less. You can survive, or you even don't get hurt. So airbag is a good thing, but it doesn't prevent the car from crashing. And now think of your IT. How often do you want to crash your system, or you have to recover from deadly cyber attacks? A car is not so bad, because you can buy a new car, you can easily rent new cars, but your IT is special. You can go to the dealer and say, give me the same thing as yesterday. I need a new version of my IT. It will take weeks and months. So availability is a very big thing, which is not cured by airbag kind of solutions. And that would be the traditional antivirus, for example. Now, what is the benefit then of introducing proactive IT security? In automotive terms, that would be the ESP, the Electronic Stability Program, that once you start to slide, will automatically reduce the gas, and it will automatically start selective braking on different wheels. So it will bring you back on track. It's a very, very good thing, because it's automatic and it helps you. So this is the next thing that we do, because then this helps us to avoid sliding in the first place. And this is an important thing. And of course, we need more than that. This is a very, very good step. Of course, we need more than that. We need actually to much more automate things, so that you even don't come close to sliding with your car. So this in the end will be automated driving. You tell the system where to go. In IT, this is still very much a dream, but for the proactive type, the middle type, we do have lots of practical examples that can be implemented today for endpoints, for networks, and also for using cloud services. So this brings us to the next and the last actually part of the story is the practical examples. So what can you actually do in terms of network security to be proactive? And there is no single thing that will make you happy. I'm not proposing here, this is the tool, this is the product, use it and you'll be safe. Security is always a 360-degree thing. You always need to look at the weakest point, and what is my weakest point? The attacker will find it, close this first before you at another already well-secured part of your IT, you increase security even more, look at the weakest point before. And now let's look at some weak points. For example, connecting IT networks and OT networks, your factory or other networks of cyber-physical systems. This is a critical point because it's happening now, very, very high speed as part of the digital transformation. So you connect machines, you will have new clusters of machine types, of well, even if, for example, baby phones are part of your money-making business model, then baby phones become part of your OT network, and you need to connect them to your IT network. What can you do, and what actually do you have to do, is you have to look at the protocols that are running in these OT networks. And whitelisting protocols or applications is a very bad idea in networks that involve people, that involve actual human users. Because human users, they will install new apps and will do things, and if you restrict them, they will complain, and your hotline will really become hot, because they complain all the time that this or that is not running on the machine, and IT is bad. But with machines, you can do whitelisting, and actually you should do whitelisting to prevent things from happening, to prevent the production machine or the fridge, the intelligent fridge, or your baby phone from starting up Skype calls to South America. How to find this out? It's possible. It's possible using, for example, next generation firewalls that look at layer 7 applications, that do application classification, and they can exactly tell you, is this machine using the protocol it's supposed to use when exchanging information between the factory floor and your management information system? Or is there something else? It's not just looking at where does the information go, it's also looking what kind of protocol, what application is running here. So whitelisting based on deep packet inspection is the name of the game. Web applications also need to be protected. Web applications, in many cases today, especially online shops, but also inside companies, they are based on a platform, they are based on a middleware. And the specialties of the online shop or your special application, they are programmed on top of a standard platform. Now, standard platforms, like all platforms, they do have weaknesses, they are vulnerable, they are not patched all the time, especially not in production, because security patching always involves functional patching, and functional patching is a very bad thing because it could, if you don't test it beforehand, because it could bring your system to a halt and then your business model would stop. So introducing adaptive access management and virtual patching for your web applications and your web services by using so-called web application firewalls or web service firewalls is not only a nice to have, has become essential. And it started to being recommended by big national security agencies such as France and Germany. And then, of course, secure site-to-site links. Never underestimate the criminal energies of people trying to find out what's happening in your production. Maybe 5 years or 10 years ago, nobody would be interested in all your production data going back and forth from your factory to the headquarters because there was just no analytical capability to process this amount of data. But now, analytical or computing power is available like this in the cloud, so people will steal actually all your production data and analyze it and find out what is your trade secret. So think about encryption, and there's solutions available that don't impact even very real-time critical connections involving many, many small packets, especially like OT and Industry 4.0 communication is like. So oh, that was the wrong. Huh? Okay. Now, another thing is cryptography. It's very easy to do. And we just heard from the previous speaker that cryptography is very far from being dead. But it can influence the performance, and also the way encryption is done can influence the security. So you may feel secure by switching on the VPN box in your standard router or switch. You can do that. But for your very critical connections, think about it, that well-known, widespread routers and switches, they are known to everybody in the world. They are well documented, the features and also the bugs. So if you use encryption that is part of a commercial standard network equipment, do it at your own risk. You can do it maybe for less important connections, but be aware that this is much more likely to being attacked and switched off silently without you realizing than if you use, and this is now at the right-hand side, dedicated crypto equipment next to the box. I know it's a little bit more effort to operate yet another box next to the thing, but it's not much more effort compared to the risk reduction that you achieve. And also, it helps you a lot in terms of performance. Encryption has to be so fast that actually your production process, your data, your big data analysis, your real-time processing is not impacted. And this, as of today, even in the mainframe world, we learned is better being done by special hardware acceleration cards. And this is available for your network as well. Now let's look at endpoints. Endpoint, completely different topic. Let's look at a PC. This is a Windows machine. You see the Windows operating system. Now, on the left-hand side, based on the user account who is logged into the machine, there's applications running, productivity, Excel, PowerPoint, whatever your company-specific applications. Really, do you want the internet and attackers coming through the internet having access to the data that you're processing there, to your PowerPoints with the business strategy, to your Excel with the production plan, the price list, all these things? Maybe not. So instead of running a normal browser, Chrome, Firefox, whatever you choose, that is also, because it's widespread, it's well known, being attacked by hundreds or even thousands or 10,000s of attackers throughout the world who are trying to break out of the browser. And more often than not, they succeed. Look at all the ransomware things. Most of that is based on a phishing email coming in. You click on the link. You go to a site that's being attacked. Most of the time, it's invisibly infected. And a piece of malware that has figured out through a zero-day exploit how to escape from Chrome or Firefox and infect Windows will do it. So why not using a very, very simple method of encapsulating the browser? You can still use Chrome, Firefox, no problem. But why not have it run on top of a hardened Linux that's running inside a virtual machine that, in addition, is not based on the user account, but even on Windows level, is running inside a special browser account, a machine account on your machine. So 3 levels of protection for your browser. And then, in addition, you see that the browser is directly connected to the intranet. There is no connection between what's happening in the encapsulated browser and your intranet. It's a very simple method. It's available. It will it is even supported in upcoming Windows releases by Microsoft through special virtualization technologies. But we have built it on publicly available technologies. It's available. We have companies with tens of thousands of users using this kind of technology. And guess what? How many ransomware problems they have? How many times they have to reinstall their PCs? Not very often. We don't hear anything. There's companies coming to us, I need to reinstall 500 PCs every month because of ransomware and other infections. This cost is gone. The time is, the uptime for employees is there. It's really easy. It's a proactive solution, and it doesn't impact usability. And the last example I would like to go is how to use cloud systems. Of course, people are using SharePoint, Office 365. They are using other cloud technologies because it's practical, it's good. It's good for collaboration across sites. It's good for collaboration inside companies. Cloud storage, cloud processing is, in most cases, cheaper than in-house processing, and it's much more scalable. But what can you do in order to use these productivity applications without placing your confidential data somewhere in the cloud where you don't have full control over which admin can read it? And here's an interesting concept that we have implemented that may be interesting for you as well. So let's look at the document on the left side. It's a Word document. And you have developed it, and it contains your business plan to start up your business in Germany, your attack plan for the German market, how to crush the competition in Germany. And you want to push it on the cloud because your colleagues in the neighboring country and those guys in headquarters somewhere, they need to look at it, and you need to work with them together to make it ready for the board presentation. So it's confidential, but still, how could you share it with them if not through, for example, SharePoint in this case? So you upload it to SharePoint, but you don't want to do it directly because then the data center, the admins in the data center who host actually the SharePoint service. Maybe you don't even know where that is in the world and which legislation applies and so on and so on. So you rather feed it through a gateway, and what the gateway does is it actually splits the information. It takes out the whole content of the document. It leaves the document name and everything, and still puts it in the cloud. Of course, it creates a new file name that is completely meaningless to the cloud hoster, to the, let's say, the SharePoint hoster. And the real content, where does it go? The real content goes to cloud storage providers. Very, very cheap way to put documents in the cloud. But first of all, it's completely encrypted. And second of all, it's fragmented. So you can even spread your information across 2 or 3 cloud storage providers. And then you can say, even if I select 3 cloud storage providers and one goes bankrupt or the data center burns down, whatever, I still can reassemble my original document from the remaining 2. So you add redundancy. This is already automatically done by the gateway. So how to then take advantage of the benefits of SharePoint? Because once you encrypt, you cannot sort and filter and do a full text search in the document, exactly what you want to do. Please find this document about the plan to conquer the German market. You type in Germany, and in encrypted documents, you won't find anything because there's no more Germany. There's just bits that you cannot interpret. So the gateway will keep track of all the content. The gateway is on-premise in your location, and the gateway will find for you where exactly which documents you need to check. And then once another user who is part of your SharePoint user group and who is also at your gateway, at your local one, or at the gateway at your partner, they will get the search results, and they will also be able to download, just as they know from SharePoint, exactly that document. And it will be decrypted and provided to them for the work. And this is all done by the gateway. So you can use cloud services, you can use cheap and available and scalable cloud data storage just by inserting a clever gateway that keeps you the owner of the data. You can still use the cloud productivity, but you don't have to let information dissipate into the cloud, and you don't know where it's going, and it may be misused. So this is actually that was the last example, how to proactively secure cloud usage. These were just 3 or 4 examples. We do have lots of more examples in these domains: endpoints, networks, applications, and cloud usage. Again, very, very summarized, the story is the paradigm shift from conventional reactive signature and feed-based solutions towards proactive security by design solution makes you actually be able to control and to define actually who should have access to your data and to prevent zero-day based exploits from entering your system in the first place, which helps you a lot later on with analyzing and fighting with the few real targeted attacks. And there are solutions available. If you would like to know more, I'll be happy to talk about this in the coffee break. And so far, I thank you very, very much for your attention. Thank you for listening.
Any questions?
Everybody prefers coffee. There's 2 questions.
So actually, how the solution looks like, it's the hardware with the software. You have a complex solution, because I heard the firewalls. Is some solutions for endpoints. So how this solution from you looks completely like a box by everything, and you came in install. How it looks like.
The solutions that we offer are actually as diverse as the requirements of the customers. So for the endpoint, for example, the secure browser, it's an application that is installed on the PC. It's being rolled out like any other application, an installation script, and it is being rolled out. The cloud gateway is either, if you really wish, it's an appliance where the software is running, but we also supply the software as a container, basically, to you. So you can run it in your data center, wherever. It depends also on the level of trust. You could even connect a hardware security module that is protecting and generating by hardware the keys that you use for this encryption. But it could also be, depending if you're satisfied with the software-generated random numbers, you don't have to use the HSM. So it depends pretty much. And the network solutions, in most cases, the crypto boxes that we use or our customers actually deploy to connect their locations, in most cases, is actually appliances. Because of the separation aspect that is very important to most of them, that they separate the crypto part from the general network part. And the challenge for us with these solutions is always that we, in spite of introducing encryption, we still allow the network to remain intelligent. If you just put an IPsec tunnel on top of it, then you lose quality of service and many other things, unless you do lots of workarounds which are proprietary. We rather, when we encrypt layer 3, if you have an intelligent, high-speed network, we do have some mechanisms that help network management protocols to move between the LAN core switch and the customer edge router. So the network intelligence for resilience, for high availability and all these things, they remain in spite of the encryption. And this all contributes. So it's really dedicated, or the form factor of our solutions, and it's not one single thing. Depends very much on the industry where it goes inside, like the protocol identification is different for smart grid networks than for production machinery, and on the security level. We can do a lot of software-only solutions, especially on endpoints. It's not practical to carry another box with your endpoint. But then for side-to-side connections, it may make a lot of sense. Long answer to the short question.
Yeah, thank you.